Hello and welcome. I am Dan Temkin, Cloud Automation Technical Sales Leader for Integration App Platform for the Americas, and I'll be your track host for this session. During this, if you have any questions for our speakers and experts, please put them in the Q&A, and we'll answer them during the course of the session. Try and make this more of a dialogue. If there's something that's really hard to bring up, feel free to raise your hand. We'll try to get you off mute as well. And then, the earlier you can ask the questions, the better, so we can make sure we have time to answer them. So that we don't get a barrage of them at the end when we run out of time. So again, presentation slides and additional resources are down below in the attachments section. If you have additional questions or discussion points that we don't get to during this session or around any of the app integrations, don't forget to join my office hours at the end of the day, where I'll have several of our speakers joining for an open dialogue. We also still have the opportunity to schedule one-on-ones up top. And let us know what you're interested in talking about, who you'd be interested in talking about, and a few scheduling options. We also do have the labs that are available next week. To go ahead and register for if different interesting topics. So this is a really interesting session. Again, I said I'm Dan Temkin. Do you trust that I'm Dan Temkin? I don't know. We'll have to see. So this is. The presentation today is specifically on zero trust. So we're really looking for how does implementing zero trust in Cloud Pak for integration play into this market. So it's we have Kim Clark, the integration architect for IBM, and James Hewitt, software architect for Cloud Pak for integration, as our two experts on the call today. And with that, as long as you trust that this is what the session is about, and that's who I am, I'll pass it over to Kim to get us going here.
Amazing. Thanks very much, Dan. And it's really great to be back at TechCon. This is one of my favorite conferences because it gets down into the detail of all the products and things. So yeah, great to be back again. I'm going to do the first half of the presentation and then hand you over to James, and I'm sure he'll introduce himself then. So Kim Clark, you've probably heard me present before, probably around agile integration. Agile integration, essentially, this idea of moving integration into the new world of cloud native and sort of breaking up enterprise service buses into smaller pieces, running them in containers, and potentially decentralizing the creation of integrations and all those good things. But we're not here to talk about that. But what lies behind that is that really agile integration is fundamentally about taking on cloud native principles. That really is the crux of what got us to the idea of agile integration in the first place. And if we start to delve into, well, what does it really mean to be cloud native? Most people immediately sort of start running to fine-grained components, microservices, and minimizing state so that you can have these stateless components running, and they can be scaled up and down, and the immutable deployment sort of benefits of that coming through. Of course, all the container technology and so on. And that's all true. That's all part of being cloud native. But as you get more and more mature, it goes through other aspects. The aspects in the middle, things to do with process. But on the right-hand side, the sort of final success factors. If you're going to be writing things or building things in a cloud native way, then one of the fundamentals of success is to change the way you think about security. And the phrase we hear associated with this most often is this idea of zero trust. Now, it's probably worth taking a moment to establish what we mean by zero trust itself. And to be fair, the term zero trust isn't new. It's been around since, I've traced it back as far as 1994, papers back that far. So, it's not a new term, but it's a very fashionable term at this moment because it really encapsulates where we've got to in the way that people are writing cloud native solutions. And it really, the fundamentals of it is that you move away from believing that you can have a strong front door on your enterprise or any part of your enterprise, and you start accepting that hackers are often on the inside already. They're able to, one way or another, deploy malicious code anywhere in your organization. They could be on the inside already. And so you've got to do what we call defense in depth. You've got to find some way of defending everything at the lowest possible level And that's become a popular idea, of course, because people are moving to the cloud and because they're building more fine-grained solutions where things are communicating across networks and things. Another thing to bear in mind, just contextually here, is that if you Google for cloud for Zero Trust, most often you'll find discussions around networking, which is a key part of Zero Trust, but it's only part of the concept. It's a bigger concept than that, and it's not just about networking, it's about a lot of other things too. And we'll come on to that in a moment, but let's delve down into this idea of defense in depth and just sort of break that out a bit. So, this is what a simplified, dramatically simplified version of security used to look like. So you had your code running on operating systems that were living inside the organization, and your developers and your administrators were talking directly to those operating systems, deploying things directly on those, and they're interacting with them directly. And the assumption was that if you put a really good boundary around the outside, then that would be enough. That would be enough to keep the bad guys out. But of course, we've known for a long time that in fact, really many hacks happen from inside the company, if not most hacks. And so the idea that code could be infiltrated, malicious code deployed by developers, by admins, or other mechanisms, means that you have this internal attack vector, and we need to think about that. And so defense in depth really says, well, what about if every single component is able to defend itself? And that doesn't just mean each individual container, it means things like the operating system itself as well, that the hosts are sitting on. And if we sit ourselves into a container platform and start thinking about cloud native deployment strategies, there's more we can do there as well, because we can take away the opportunity for operators and administrators to interact directly with the individual runtimes and have them work at arm's length through GitOps and through source code management, and have that only ever deploy things, whether it's infrastructure or whether it's new code, through a pipeline. And that pipeline then works with the control planes and operators, as we'll see later, to deploy the code in a fully automated fashion. So there's a lot less flexibility in terms of what the DevOps guys and the site reliability engineers, as we now call those roles, are able to do with the environment. So that's kind of where we get to with this sort of overall idea of defense in depth. And so if we then just step back a moment to sort of bring ourselves back to products and the products we're talking about here, IBM Cloud Pak for integration is our key topic area here, where we've got all of the different componentry sitting inside a single pack. What we've tried to do is to make that make the security around that as straightforward as possible. And today's presentation is very much focused not so much on how you customers actually use the product, but on what we've done to architect the product to make it easier for you to use. So we're really focusing in on, what have we done to take advantage and leverage things like OpenShift, to enable consistent security principles and a consistent security model across the whole pack, regardless of which area of the pack you're in, what capabilities you're using, and leverage the benefits of things like OpenShift. And of course, we can give you more benefits if you're running the pack on OpenShift, but we recognize not everybody is. So you can get some benefits if you're running on a container platform, and so on and so on. We do our best to cater for you wherever you are, but clearly there's a lot we can do with the OpenShift environment. A quick sort of look at this. If you remember the agile integration picture at the beginning, so this is sort of a diagram built out of the furthest right-hand side of that diagram. The most advanced you could get, the most decoupled with all the applications. All the integrations are very fine-grained. They're living alongside the applications, being built by the application teams. The APIs and potentially events as well are being exposed by the application teams, so very decentralized in who's doing integration and who's achieving it. What we're trying to do is enable those teams to have the simplest possible way of defining the security model, and defining it identically regardless of what capability you're using, so multi-style, all the different aspects, but also hybrid cloud as well, so whether it's on-premise or whether it's in the cloud, and what vendor you're working with in the cloud as well. And that's again where we get significant benefits from being able to sit on this common platform. So for the purposes of this presentation, we've broken down Zero Trust into four key areas, and I'm just going to run through those quickly and then hand over to James to give you some more detail. But we see these as the most common discussion points that we've had with clients over the years, and especially as they're moving into the cloud, as the things that they're most worried about in the space of security. So begin with identity, and this is another one of those concepts that's not new. The idea of identity as a perimeter, rather than the perimeter being the physical firewalls and demilitarized zones. Those might still be there, but they might be serving a subtly different purpose than in the past. But it's been over the last, well, near 20 years that this idea of deperimeterization, is what they used to call it back in 2004, has been gradually evolving. This idea of saying, well, that outside perimeter isn't enough. We need to think about how we lock things down internally. And one of the fundamental ways of doing that is to make sure that everything, not just people, but resources as well, everything has an identity. And so every container that's out there has an identity. Administrators, of course, have identities. End users have identities. The applications that are communicating to the API gateway have identities. And those identities even federate and change as they go through the system. So you have a user identity that comes in perhaps over a mobile application that might need to be federated to a different type of identity as it goes to a SaaS application in the back end. And these are the kind of complexities that, more so than anybody else, we're trying to solve in the integration space. This idea of, which identity are we working with is really critical when you are fundamentally the middle guy. You're the one that is taking in identities from one side and trying to transmit them on the other side. And then, we've now broken into much more fine-grained integrations, lots of different separate integration containers potentially, queue managers running in individual containers, and so we need to make sure we establish good identities between those as well. So identity, a really fundamental aspect, and going hand in hand with that then is this idea of privilege. So, okay, so I know who you are, but what can you do? What are you allowed to do under that identity? So as an integration running within the Cloud Pak for integration, what access do you need to have to the platform? And by that I mean the Kubernetes platform. What should you be able to do through the Kubernetes API? What should you be allowed to do on the operating system? What volumes should you be allowed to see? To what extent can you soak up memory and CPU? So control over those resources, and what access have you got to the network, and what things on the network have you got access to? There's a lot to think about, and it would be really nice if there was a standardized way of doing this, and thankfully there is. That's what we're going to come to in a minute, that once you've got the identity, you can use things like role-based access and network policies and things like that to assist in simplifying the way that you handle how these small-grained pieces can talk to one another. We have to, we're talking about security, we have to talk about data. So fundamentally, we've got to make sure that the data, customer data, individual data, personal data is safe, whether it's at rest on disk, whether it's in transit, and also in terms of who's accessing it and what they're supposed to be able to see in the first place. And so we need to be able to secure channels in various different areas that we're communicating. We've had deep abilities to do this in the individual products. So you look at advanced message security in MQ, we've been able to do true end-to-end security all the way from disk and the queues on one side through the transition all the way through to the disk and the queues on the other side. And those are the sort of things that the if you like, the application level of our products already do. But then we've also got to think about how we do that with all the other bits of communication that are going on around the Cloud Pak. So how it's communicating with the across different integrations, between integrations and queue managers, between API gateways and integrations. We need to be able to make sure that those are secured and in various different mechanisms as well. And then the fourth aspect is kind of a subset of what we'll be talking about with data security. There's one aspect of data which is particularly precious, and that's credentials and certificates and things that allow you to do things. So where do we store those? We need to decide where we're going to put those particular pieces of data, those secrets and certificates and things like that, that is only to be seen by the people that absolutely need it. So they need the most fine-grained and specific access. And there are choices. And so we've tried to make those choices available to you in standardized ways, again, using the standardized mechanisms available in OpenShift. But also there's going to be a little bit of discussion around choices between, for example, using secrets in Kubernetes compared to using vaults, or even combinations of the two and things like that. So there's other things to think about there. In a gateway, do you need the hardware security modules in there to be able to put things in so that they're opaque and you can't get them back out again. So lots of things to think about there. That's a special class of data, if you like, in terms of the secrets. So at this point, I'm going to switch across to James. I think he's going to steal the screen off me whilst I'm talking here. But what we're going to do is look at this from a perspective of a code attack. It's almost like the worst case scenario, if you like. If you can get into the code that's running on a container in the platform, then you've effectively got open access to all sorts of mechanisms. So this gives us the opportunity to talk about all the different routes in. And so James is going to take you through these different styles and talk about what we've done in the pack to simplify it and hopefully make your life easier as a consumer of the product. So all yours, James.
Cool. So Kim promised I'd introduce myself. Hello, I'm James Hewitt. I'm one of the senior architects for Cloud Pak for integration, trying to pull together all of our products and make sure that all of the integration software that you know and love and works really well outside of containers and outside of Kubernetes native architecture works really well inside, and like Kim's saying, follows all the best practices and is secure by default. So Kim said that this presentation is mainly to show you about things that we've done to make sure our software is secure. I've tried to also make sure we've got a few little bits in there to help kind of share some of the lessons that we've learned about what we're doing, so that you can take those away and use them in your deployments as well. So yes, like Kim mentioned, that we've got four main highlights here. So this is kind of an agenda for my section. We're going to go into a bit about how malicious code could attack the operating system, could attack via the network, could attack via the Kubernetes API, which is obviously a brand new attack surface when we're talking about running things in a Kubernetes native way, and how you can help protect your credentials. It's fairly obvious how someone could attack using a secret. They've got your credential and they can log in and do things. I tend to like to try and take a glass half full approach to most things in life. When it comes to security, I try and take a glass half empty approach and assume that if there's any vulnerability anywhere in the stack, we need to fix it. Because as soon as you kind of find one vulnerability that might let you into to get some malicious code running within a container, all it takes is another little vulnerability to start allowing escalation of privileges or access to services you shouldn't have access to, and all kinds of things like that. So first off, how do you avoid bad code entering the system in the first place? And this is a crazy question, really. I mean, it is very hard to stop any bad code from getting anywhere. There are a lot of things you can do to help, and what we've got here is one example of how you could do a development pipeline that has the least possibility of bad code getting in. I mean, this whole presentation really is based around the fact that there's going to be bad code and it's going to get places, and we need to limit its impact. But for example, in this development system, we could look at this as perhaps and it's a fairly generic development system, but we could look at it as producing custom App Connect containers to run in App Connect integration servers, and doing that in a kind of secure way. So you can see that on the left, we've got the only access to be able to provide code and change what's going on in the system is via SCM. SCM is awesome. It allows you to do peer review. It allows you to do audit. And it means you can roll stuff back. It's really good for being able to control systems from the outside. So moving all of that important stuff left. At the top there, we've got a certified container registry. So that's where we're saying, okay, well, we provide some App Connect images that you might want to extend by putting on your bar files and your configuration, anything else you might need to do to it. So use certified containers for that. One of the steps that we don't have in that CI/CD pipeline down there that we could add is things like when you pull that certified container out of that repository, you should be verifying its signature and making sure that you're getting exactly what it is that you think you're getting, and that IBM has signed it and said, yeah, that's exactly what we wanted to give you. Then as the CI/CD pipeline progresses, you build your image, and then in there you want to test that image, and you should be including vulnerability tests there to say, do we have all the latest versions of the open source components we're putting in? Are there any known vulnerabilities in those? Have we made sure that we haven't accidentally opened up other holes by allowing different users to run these containers in different ways, right? Something else that's useful to do, and kind of just a part of the whole landscape of trying to make your whole environment more secure. So then this automated pipeline is the only thing that should have access to the control plane. So once it's gone in and it's been tested and we're happy that it's good, we'd normally have a manual button for someone to press to say, okay, we've blessed this one, this can now be deployed. So that then goes out to the operator. We tell the operator it's this exact image we want, this immutable image from this container repository that the build put it in, this exact digest, we want that to go into the namespace. And again, that's all controlled over on the left via GitOps and try and keep things safe. But I mean, this is a good start, but it's not enough, right? So from here, we'd want to take those images and say, well, this is our development cluster. We want to push those up into our tests and our stage and our production clusters. How do we make sure that it's exactly the same image? We can sign things there. How do we promote them? How do we make sure that the bad code stays kind of as constrained as it can be? All kinds of other things that we could be doing. Deploying this system itself, you need to do very carefully, right? So this whole system, this whole pipeline, that all needs to be controlled in GitOps itself. Because if you get a bad actor who takes over your CI/CD pipeline, they can just tell your tests they all passed. I mean, that's easy enough. So yes, not to be too hyperbolic about it, but security is hard, and we have to work very hard to get it right. So back to our agenda then. How can malicious code, we should say, in a container attack via the operating system? So containers are brilliant, right? They can take a process and they can wrap it up in a little box, and they can say, well, we want this container to be safe, right? But if you don't actually use those mechanisms, then running a container in a privileged mode with the root user, which is something people often do because it's easier than worrying about, oh, how do I give it access to this file or this mount and all that kinds of stuff. If you just run it in the most basic mode possible, it can just get to the operating system. It can break out of its own chroot jail. It can start attaching itself to the network. It can run as root and do anything on the host nodes it wants to. Mount directories and install Bitcoin miners is a very popular one at the moment. So how do we stop it? In OpenShift, what we have is security context constraints. There's a very similar mechanism in Kubernetes, in plain Kubernetes, called pod security policies. And what these do is they say, okay, well, for this container, what is it allowed to do? What can this pod actually do? And they can stop containers doing things like running as privileged. They can force it to run as certain user IDs. They can apply SE Linux profiles to it. They can define which network addresses, network interfaces they can use. It can change the capabilities of the process within the kernel, all those kind of things. The most important security context constraints that you'll find in OpenShift are the restricted and the privileged ones. Restricted is the default one, and if you don't change any of the configuration in OpenShift, restricted is what everything will run as. If you are running things under a higher level than you should be, like running it under privileged, that's when code can break out of its container. Another one that's interesting is the NEUID SCC. That one is designed to allow containers to run as the ID embedded in the image, because you don't have to predefine the user ID that runs for that container. The only way that can work is if it's made higher priority. So if you assign the NEUID SCC so that a pod is able to use it, it will use it. Whereas in other cases, OpenShift will intelligently look at what a pod is asking for and apply the most restrictive SCC that it can to it. So that's an interesting little niggle to know about. So that's a quick cover on SCCs. I mean, the way to apply SCCs on an OpenShift cluster, you can either edit the SCC itself and say these people are allowed to use it, or you can use role-based access control and give it the use verb. But that's probably going into more detail than we need for this presentation. So what's up next? Network attacks. So once you've got malicious code running in a container, obviously it can do anything. So it can run servers, and if it runs servers itself, then it can allow in external traffic, unless you're blocking it, to kind of communicate with the outside world, which means you've got kind of botnets running inside your Kubernetes cluster, and that's bad. The other thing the malicious code can do is obviously attack the other containers within your Kubernetes network. Unless you're securing your Kubernetes network, which you should be doing, then if malicious code's in a container, it can try and hunt out what other services are running. And if it can find something that it knows has a vulnerability, that's an easy way for it to kind of spread around a bit and maybe find some more pods that it can take over, or more service accounts that it can try and use the privileges of. So how do we protect against network attacks? So in a microservices world, there is a pattern called microsegmentation. And the idea here is that you take every kind of set of applications or tiers or whatever it is, and you kind of provide the networking definitions, the software-defined network for those individual environments, and use them to protect them against each other. So that's the kind of pattern that we take on to do this. The way that works in Kubernetes is with a number of different mechanisms. So we've got 5 different mechanisms on the left there that we've enumerated that help kind of perform this stuff. So we've got network policies, which are brilliant. You apply them directly to Kubernetes, and it defines what pods can talk to each other and what pods can talk to the outside world, and what traffic can come in from the outside world to pods. So in CP4I, we've defined when you deploy software through CP4I, it comes with network policies that define this is exactly the traffic that this pod needs. These are the other pods it needs to talk to, and it kind of just sets up a secure environment by default. The way that network policies work within Kubernetes is quite interesting. If a pod has no network policies that select it, then that pod will be by default allowed to do any networking it likes. As soon as you apply a single network policy to a pod, that pod will then only allow the traffic that is in those network policies. So best security practice within Kubernetes is to apply a network policy to every single pod. And very best security policy is for every namespace within your Kubernetes cluster, you should have a denial network policy that says this pod can't talk to anything. Because then for each network traffic, each route that you do want to open up, you have to create a network policy, and then they're additive and they come together. So the way that CP4I has done this is we've said, okay, well, we're going to secure all our pods and make it so that you as users can perform best practice and deny all traffic in the cluster. Because if you deny all traffic in the cluster, our network policies will mean that we are just right and just ready to go. The second mechanism is things like MTLS. So wherever you've got applications talking to each other, like web tiers talking to application tiers, or application tiers talking to data tiers, you want to try and make sure that those are properly secured, and that each side of the connection identifies itself to the other side. And using MTLS is really good for something like that. We do this in CP4I. So where we're using MTLS, we have internal cert manager certificates that set themselves up and allow us to verify credentials between the different pods. So we try and make that as easy as possible for you to install, and as secure as possible when you're running it. MTLS is not an easy thing to set up. Firstly, how do you distribute the certificates securely between all the different places? How do you have the right trust stores available to all the pods? And then going on from there, the thing that most people realized 90 days after they first set up their infrastructure is, oh, how do we rotate these certificates now, because they're all going to expire because we set them on sensible time limits, right? So using something like Cert Manager is how we do that. Cert Manager is a component that we install as part of the common services with CP4I, and we recommend that you use it for your own purposes as well. It's really helpful. Another mechanism is multi-tenant mode. So in OpenShift, you can actually switch your cluster from network policy mode to multi-tenant mode. And multi-tenant mode basically says, allow all my pods to talk to each other if they're in the same namespace, but not if they're in different namespaces. You can then kind of link namespaces together and do things like that. But if you're running in multi-tenant mode, what you won't have is the ability to use network policies. So instead of using multi-tenant mode, we would recommend running in network policy mode and using a default denial policy in every namespace. Another mechanism for securing pods and traffic between pods is Istio and other service meshes. So Istio will run a sidecar with each of your pod, and it'll basically hijack all the traffic and can apply TLS to it for you. We don't need that for CP4I because our services are already using TLS. We don't have any connections between any of our pods that don't use TLS. And we think that's very important. There are still other very good reasons for using Istio, things like doing blue-green deployments in canaries and all that kind of useful traffic management stuff. But for TLS, for CP4I, you don't need it. But we will run perfectly happily with it as well. And then finally, API management. So obviously, we're big fans of API management. And it's much easier to allow an API management layer to apply all of the right identity-based access and rate limiting than having to do that in every single service. But then you do also have to make sure you think about, how does my API management layer identify itself to all of my application layers and APIs and things like that. So it's a complicated area, networks in Kubernetes. I've often seen Kubernetes described as a networking technology, which it almost just is. But if you do it right, it can work really well. So what's next? How can a container attack via the Kubernetes API? Okay, so if you've got some malicious code running in a pod, by default, in every pod in Kubernetes, every pod will be associated with a service account. And by default, Kubernetes will inject a token that allows that pod to use that service account into the container itself. So every container is able to just ping the Kubernetes API and say things like, hey, who am I? And do basic things. Usually, that user shouldn't be able to do much. That identity shouldn't be able to do much. But you do have to be a little bit wary about if someone has incorrectly configured the role-based access control in your cluster. If you have accidentally given a service account more access than it needs, it can then do things like run other pods, which might run different images and have different service accounts, or read all your secrets, or break things by just deleting loads of objects in your Kubernetes cluster, or change its own configuration and make itself more powerful. I was working with one user luckily on their development cluster, where we were trying to work out why a number of services were running themselves under the NEUID SCC. And we couldn't work it out because the NEUID SCC looks fine, and there was no kind of extra roles assigning the NEUID SCC to everyone, until we realized that actually what they'd done was they had assigned cluster admin to everybody. And because cluster admin is able to use NEUID SCC, and because the NEUID SCC is more powerful, it has a higher priority, it was being used by default for all the pods. But that basically meant that any container in their whole system could access the API server, take control of any pod, any node, a whole load of bad things. We did then go on and check their production system, and it wasn't in their production system. So that at least was good. So how do we stop people from taking advantage of service accounts that they've got access to in their pods? So there are a number of things you can do, and in general, it's about least privilege, right? So the Kubernetes API at its core is a CRUD system for the resources that are in the cluster. It's controllers that do all the real work, kind of native controllers like the deployment controller and the pod controller, and then operators like the CP4I operators who are controlling the CP4I resources. And so in general, the pods themselves, the applications running in the pods, don't need Kubernetes API access. So one thing you can do is in your pod, you can say, hey, don't even give this pod a service account token because it doesn't need to talk to the API. And that's a sensible thing to do. And that's something that we do in CP4I for any pod that doesn't actually need to talk to the Kubernetes API. Other than that, our operators, when they are creating operands, so they're creating the deployments and the pods and the service accounts to go with them, we will make sure that when we're creating those, we only give the very minimum roles that we need for that pod to do its work. So, for example, where we do need access to the Kubernetes API, event streams, for example, needs access to the Kubernetes API to find out what node a particular instance is running on so that it can properly spread out all of its partitions across the different zones in the cluster, right? So we give it a service account that has access to just that, and that's all it needs, and that's that. We just let it kind of take that and go. There is one interesting little easy security trap to fall into around service accounts and namespaces. If you have a service account in a namespace, any pod can use it. So if you've got a namespace that's maybe assigned to a team and that team can create pods in that namespace, they can use any service account in that namespace. So if you have another service running in that namespace which has more privileges than that team is supposed to have, they can very easily hijack that service account and use it to do privilege escalations. So it's really good to make sure that when you're separating stuff with namespaces, you do it on a proper logical basis and you don't kind of put extra stuff in there. One of the things that this has affected within the way that we have developed is the service accounts that our operators need and the service accounts that our operands need. Obviously, the software that we deploy doesn't need as much access as the operator itself, because the operator needs to be able to deploy software in Kubernetes. So where we can, we separate the operators and the operands from running in the same namespace. So if you're running Cloud Pak for integration in a kind of whole cluster scope, those operators will be installed in one namespace, and all of the actual components will be running in other namespaces, so that it's all nice and safe, and we can't accidentally kind of allow privilege escalations. So that's a good note for anybody else as well. When you're creating services, think about how that can happen. Okay, what's next? How can a code in a container attack via secrets? So yeah, obviously, if code can get hold of your secrets, it can do things, right? It can get credentials for database access, and then it can go and delete everything in your database or send it off to Russia or wherever it is it's going to send it off to. And it can grab hold of your certificates, and it can use those to talk to other services via MTLS and kind of identify itself in places it shouldn't be. The malicious code in the container will have access to any secrets that are already mounted into that container. If the associated service account with that container has access to also has access to secrets, then it can read more secrets based on what that service account can read. And it's interesting to note that within Kubernetes environments, Vault access also tends to be based on the service account access, which kind of allows you to take that example we had before of saying that anyone who can create a pod in a namespace can use any service account. That means that anyone who can create a pod in a namespace can access any of the Vault certificates that are assigned to the service accounts in that namespace. So what do we do about secrets? So Kubernetes secrets, the only real encryption, well, they don't have encryption, they have encoding. They're base 64 encoded. They're not particularly private. And by default in Kubernetes and in OpenShift, actually, the etcd database where all these secrets are stored is not encrypted. So if you get access to those backend disks, then you can get access to all of those secrets, which is not as good. So what can we do about that? Well, we can encrypt etcd, or we can use vaults, and we can do all kinds of other things. So vaults in Kubernetes use a number of different techniques to be able to load secrets into containers. They use init containers, where when you start up the pod, an init container will connect to the vault and pull those secrets down and mount them into a directory so that the actual service can use them. They can use CSI-based volumes to mount secrets, where you mount a volume into your container, which is a specific volume that points at a vault, and the secrets appear in there. And then you can obviously do direct access as well, where the application itself just connects directly to the vault and says, hi, I'm this application, can I please have my secrets? Most of these techniques are, like I said, authenticated on service accounts. So if you can make a pod, you can access any of the secrets linked to the service accounts in that namespace, which really means that from a pure security perspective, from a pure could someone steal my secret perspective, Kubernetes secrets and vaults are reasonably equivalent. If we're looking at malicious code running in a container, what can they get hold of, right? Vaults do have some advantages, though, around management of secrets. So vaults are good if you've got secrets that you're using inside your Kubernetes cluster and outside your Kubernetes cluster and how you want to manage them together. They can be good at enabling dynamic credentials. So let's say you spin up a new service and you want it to have kind of read-only access to a database. You can get that credential created at the point that that service starts and asks for it. And then as soon as that service goes away, you can delete that credential. So those credentials are short-lived and harder to take advantage of if they are compromised. Vaults can do much better auditing of how those secrets are being used as well. So they can write down every time that a service asks for a secret and starts up, it can write it down and say, this service has been using these secrets. And that makes it really easy to identify where perhaps old secrets are being used or secrets that you thought shouldn't be being used anymore are still active. They can be good for things like rotating secrets. So if you want to change your database password every 30 days, then the Vault can do that for you and just go and change the password and then hand the new password out to all of the clients that need it. And they can, on top of that, they can restart pods and things when those secrets change. So if they have rotated a password, they can then go and just restart the client and say, hey, now you need to use this new password instead of the one you were using. But vaults can be quite complex, and like I said, I mean, within it containers and volume access and stuff, that's quite complicated to set up, and you've got to link your vault into your service accounts and all kinds of things like that. So one of the common patterns that I personally recommend, and I know that IBM Cloud recommend as well, is to actually use the secrets in the vault to seed Kubernetes secrets. So you will set up an interface that says, hey, I want this secret in my vault to exist in my Kubernetes cluster as a secret in this namespace. And then the management system can kind of, whenever that secret changes in the vault, update it in the Kubernetes cluster. That's much less complicated to deploy. You don't need init containers and things. It means the vault is no longer a single point of failure, because obviously if your vault goes down, you wouldn't be able to start up new services if they were pulling in their credentials from the vault every time. But you still get all those management benefits of a vault around rotation and audit and things like that, which is good. Another alternative to going all the way out to vaults that's kind of come up more recently is called KubeSeal or sealed secrets. And that's where you can actually encrypt the secret. So not just base64 encode it, but encrypt it with an encryption key. And then you can put that into your GitOps as a sealed secret. And then when that sealed secret gets pushed onto the cluster, you have the decryption key on the cluster itself. And that's what kind of converts that sealed secret into a secret. It's got its advantages and its disadvantages. It's reasonably easy to set up. The tooling allows you to do all kinds of, a lot of the management that you can do in a vault. So kind of the rotation and then rotation of the encryption keys for the secrets themselves as well. But it does come with some disadvantages as well. If someone manages to steal one of the decryption keys, and they could then look in your GitOps and just get all of your secrets at once, which is not brilliant. But then, I mean, vaults are going to be susceptible to that as well to some degree. So what do we do in CP4I? So in CP4I, whenever we need a credential to be provided to one of our services, to one of our integration capabilities, we will ask you to mount that as a Kubernetes secret so that we can get that, so we can manage that correctly. In CP4I, we very explicitly do not create any TLS certificates unless we have a plan about how they're going to be rotated. So like I was saying, that's where we rely on things like cert managers to make sure that we've got that kind of end-to-end certificate management thing going on, rather than just creating a certificate and then not worrying about what happens in 90 days later. When we are using secrets, we try and mount them to our pods rather than using them as environment variables, which means that when they change, the service running within the container can identify that it's changed and use it without any downtime. That's quite useful. That doesn't help with security, but that helps with being able to change secrets more often, right? So it's not directly good for security, but it means that you can rotate secrets every day if you want to, and you won't get have to have downtime for changing passwords and things. And we're working on ways to more tightly integrate with Vaults, so to try and find ways where we don't need you to try and configure our to change our pods and have new init containers and volumes that need management, so that we can kind of directly talk to Vaults instead, so that we can just take those secrets out and use them. Yeah, and that's it on secrets. So, any questions before I hand over to Kim to wrap us up?
There was one that crept in actually, which is a nice one around, is there a way to scan an MQQ manager for vulnerabilities? And Dan's put an answer in the chat there, which is very much around the things that you might have added on top of that queue manager. So the MQ-ini and things like that, the code and the config that you've added. That you know, of course, you could put in rules that test that. I guess the other thing to add to that is that if you're using our certified containers, then we've already run some vulnerability checks against the images, and that's true for MQ, and that's true for ACE and all the other pieces of the pie.
Yeah, and actually, I just jump back to this slide because one of the important things here is not just that you build and test your components and then you release them. Everything that you're currently using in production, you need to continually vulnerability scan, right? Because new vulnerabilities come out in software and in open source libraries and in any software, obviously, that might already exist in a container that you're running, and you need to know that that's there as soon as possible. So within IBM, all of our certified containers that are currently in service are scanned every day for vulnerabilities, so that we can identify them as soon as possible, release new container images, and get those updates out through the operators, so you can update your systems as quickly as possible.
I think it's just worth hearing what James just said there, actually. So you know, that's saying that, you know, you can upgrade the runtime underneath an integration or a queue manager when a vulnerability comes out in a fine-grained way, and the operator will help you do that. Now, compare that to perhaps where you are today, which might be, oh, I'd like to migrate to the next version. I'll set up a migration project, and we'll, you know, regression test all the integrations and, you know, all that sort of thing. This is a very different way of working, and you know, the opportunity to be able to, you know, push security patches through to production is there. The cautionary note, I'd say, of course, is that does imply that you've also put the time in to create the automated tests so that you can push things through. And that's not a small piece of work, especially if you've got 400 integration in production and so on. So, you know, there's two sides to this story. One is that the technology is allowing us to do this fine-grained individual upgrading of pieces, but it does mean you've got to work differently.
Yeah. And that's kind of partly what CP4I is all about, right? Is providing those components that can be easily built upon and in the cloud native way, and building on top of OpenShift, where you have built-in CI/CD pipelines and built-in release container repositories that are already there and ready to go, so that we can provide things like Tecton pipelines to build customized ACE images much more easily than we could in the past.
Absolutely. So feel free to drop to the last couple of slides. And one thing that's worth saying, I think, is that, you know, the term zero is a good starter for an argument, isn't it? Right. So do you ever get to zero trust? Do you ever get to a point where, you know, well, if you did, you'd lock everything down and nothing would work, right? So you never get to zero trust. So you have to think about how you're going to get to approach zero trust in a way that makes sense for you. And I used to, you know, when I was out in the field, my security discussions always began with, you know, what level of paranoia do you want to adopt? Because that's really what it's about. You know, what are you nervous about? Which things matter most to the business? And that's basically what threat modeling is. You know, you take a step back and you say, well, you know, we will invest time in a solid pipeline. We will invest time in converting to a cloud native way of working so that we can get security patches through. You know, each one of those things you look at and you say, is it worth my investment for the benefits that I might get from it? But you know, there is always a cost. and adding layers of security. What we've tried to do, as James has said, is to make some of those things a default. So things like the way that we've provided network policies to all of the components, so that if you then choose to take that particular level of paranoia where you have a trust nothing, deny all, then our stuff will still work. And so if you implement a service mesh, the service mesh, forces that denial immediately, then it will still work. So that's the kind of thing we've been doing to try and make sure that, as you take those steps forward, it doesn't necessarily break your system. Moving on to the last slide then, just see how we get to there. So this is kind of a summary slide around zero trust in general, and it sort of reinforces a lot of the points we've talked about. And I think there's lots of things that James took us through that hopefully stayed in your mind. So things like the importance of the scope of service accounts and their relationship to namespaces. So understanding that once service accounts are placed in a namespace, anything in that namespace can access those. That means that whatever privileges they have, including their privileges to access secrets and things like that, is suddenly immediately inherited, and that has some fairly radical effects on your choices architecturally around what you're going to use namespaces for, or projects as they're called in OpenShift. They're more or less the same thing. So I think that's one to take away as a to keep in your mind, is that you've really got to think about how you're using namespaces, and bear in mind that we've already done the sensible thing of separating out things like operators into separate namespaces, so that they won't permeate overzealous permissions. So namespaces, service accounts, we've had a little bit of a chat about the certified images, which is important as well. So knowing that you can trust an image that's been brought down the line, and being able to check those images on a regular basis as well. So those sort of things are important. I guess we didn't really talk about it as an identified topic, but there is this idea of shifting things left into development, just generally shifting testing left and things like that, and that especially applies to security. And I guess a lot of what we're doing in Cloud Pak for integration is trying to shift some of those things so far left that they're not even part of your development cycle, they're part of ours, right? So we're trying to shift some of the security concerns right down into product, so that we've already solved them for you. And then when you implement with the product, those things are already there. So yeah, shifting left for security, we've done some of that for you, but of course your pipelines and things need to incorporate those too. On the final slide, we've just got a set of links for you around many of the topics we've been talking about. So we've dropped your screen share there, James.
Yeah, because I realized I hadn't picked up your final slide. So
no worries. Yeah. We can get to that one another way. There we go. Well done. So yeah, we've just sort of pulled in things around zero trust in general. There's a good document there that describes zero trust architecture from 2020. As I say, it's a nearly 20-year-old concept, but you need to sort of read about it in today's context with cloud and things. We discussed briefly agile integration and cloud native at the beginning, so some definitions around that too. And then on the bottom right there, we're dropping down to some of the more detailed links, and hopefully all of these are accessible from the PDFs that you can pull down, so you'll be able to get through to these individual pieces. We're more or less on the hour. We've still got time for a question or two if one pops up. Have we had anything come through?
Yeah, and can we have till 5 after? So if there are questions. So I know there's a whole lot of links here. They are all accessible. If you go down into the attachment section, which is below this, you can download the deck. And I have checked all the links are working great in the PDF format.
Good. Great. Yeah, so questions are welcome. I've just seen in Q&A. Let's just have a look at what that question says. Network security from MQ channels. Service mesh to proxy the MQ channel, or running MQ IPT in a pod. Right, so you're looking at how to you're considering whether you could use a service mesh. In number one, you're saying, could I use a service mesh to proxy the MQ channel? Now, service mesh does many different things. I think we'd probably have to ask ourselves whether we even need to do that. So if you wanted to, for example, set up secure communication, MQ channels can already do that. So you wouldn't necessarily be needing to do it for those sort of things. What service mesh brings in is a lot of other things that are really more focused around HTTP traffic, and service mesh itself is really more focused around that level. So I think that if the MQ protocol communication, you probably wouldn't use it over. But then you mentioned in part 2 using internet pass-through. If you happen to be using internet pass-through, then that would allow the service mesh to step in, certainly. But I think you may be sort of trying to replace some of the things that MQ is already doing. It's really, the service mesh is, as I say, generally more focused on IP and HTTP traffic. I don't know, Dan and James, whether you've got any thoughts on that particular topic.
Yeah, I think it would depend a lot on where your two ends are running. If you're talking about how do I connect from my data center into the cloud, then there are things you can think about in terms of, well, can I use a VPN to get into my cloud? Are there kind of private link technologies I should be using? If you're talking about just connecting between two MQs in two different parts of your data center, then the answer would be different, obviously.
There's a lot of things that service mesh does that you wouldn't need in queue manager to queue manager communication. So things like it does, circuit breaker patterns and things like that, which, A and B testing capabilities. None of those things would be relevant in that particular context. So, I think many of the things that the service mesh does are probably already handled at a lower level in MQ, if you like. It's a great question. Thank you.
Yeah.
Let's see.
I do love the security area. Security is fun to me. I think it's a way to really let your OCD out, because for every little area where something might go wrong, and you're trying to say, well, if this and this and this and this happen, then could someone get in? That's it's good exercise. It's good mental exercise.
Keeps you awake at night.
Yeah. Well, for the wrong reason sometimes.
Well, I hope this has gotten everybody thinking about, that this is a pretty complex area. It's a lot of layers to think about, a lot of interdependencies between how Kubernetes works and, how all these different, the secrets can be stored, the vault, that there's not a one, answer for, one fits all solution. With that, I'll request, if you can provide some feedback, what you think, what would you like to hear more about? We posted the poll in the chat as we're wrapping up this session. We really do appreciate everybody's time in here. And if again, as you're mulling some of this over the course of the day, please feel free to join our open office hours later today, where we'll have, be able to have a broader discussion, if you'd so like, on this or any of the other topics that we've covered inside of the app integration channel, or this track, and then of course join the other tracks as appropriate. And hope you have a great rest of your day at TechCon.
Thanks for coming along.
Yeah, thank you.
Thank you.